All right, taking a look at reflections and just taking the opposite of a coordinate, the thing that I wanted to emphasize was the rule. And this is the algebraic rule or the way that you can write it. So anything that's going over the x-axis is going to be the opposite y value. So you have your original coordinates of x, y, and then it will take the opposite of the y value. So here's an example of what that would look like. Say I have a and a prime, and it's been reflected over the x-axis. That would mean I have my coordinates of x and y, and they're going to be the same. So I can go ahead and just do this, and then I take the opposite of the y value. That'll give me a reflection over the x-axis every time. It pays to know the rules. So here's what that looks like for a and then a prime. The line of, way off. The line of reflection would be 1, -1. There we go. So you can see that whenever we had the line of reflection, which was the x-axis, we counted the distance away from the line of reflection, 1. And then we go to the opposite side of it, 1 away. The same applies whenever we have the y-axis as the line of reflection. It's the same idea. Is the algebraic representation for that is you have your xy coordinates from your pre-image, and then you have going over the y is going to move it side to side. So that'll give you the opposite x value. The way that would look is there's your original, here is your image. That'll give you the opposite x value, and you can see how this will work. We go over. That's 1 away, so a prime. That checks out as going -1, +1. One more thing that I want to show is that sometimes if you have a figure that is in multiple quadrants and then you do a line of reflection through through the shape, that it can make the shape overlap and it looks weird. So I'm going to go ahead and just do that real quick just to show an example. So if I wanted to use the line of reflection as the y-axis, that means I have A, B, C. That is -2, 2. B is 1, 2. And C is -1, -2. I know that whenever I'm going over the y-axis, it's going to be the opposite x value. So A prime, B prime, C prime. Opposite x value is going to be 2, 2. Opposite x value is -1, 2. Opposite x value is 1, -2. So I already have these, and I wanted those as a point of reference. So I'm just going to do the same thing like the old school way of just going, how far away is it from the line of reflection? B is 1 away, so I'm going to go 1 away over here. B prime. That should be -1, 2. -1, 2. Check. A is 2 away from the line of reflection, so I'm going to go 2 away. A prime is 2, 2. Check. And then C is 1 away from the line of reflection, so I'm going to go to the other side. There's C prime. And you can see how the shape overlaps with itself, and that's perfectly fine. This is a way that symbols are created. This is a way to use math to make pictures. And you can see that based on the rule, the coordinates checked out. One last thing to talk about is if we have a line of reflection that is, say, x equals -2. That would be on the x-axis at -2. Now, if we were to make a horizontal line, you can see that the line of reflection would just be the x-axis. That's not what we're looking for. What's going to happen is there's going to be a vertical line crossing through that point. There's your new line of reflection. And the same concept applies, that if you have a point right here that's 2 away from it, reflecting it would put it 2 away from it on the other side. Now, the same also applies if you have a line of reflection where it's y equals 3. You go to your y-axis at 3. If you created a vertical line, it would just be the y-axis. That's not what we want. What we want is a horizontal line that's crossing through the y-axis at positive 3. The same thing would apply. And if you had a point, you count the distance from the line of reflection and you go to the opposite side. These are the basic ideas of reflections. Know that a reflection over the x-axis takes the opposite y value, and a reflection over the y-axis takes the opposite x value.